Here we look at the use and functionality of a basic per and polyfluoralkyl substances data model and library created with Microsoft's Excel and Power BI. Microsoft's Power BI software includes much of the functionality of Excel 365, facilitates the incorporation of any necessary contextual information, and allows for sharing of models, such as that used for demonstration here. Several web-published Power BI environmental data models and libraries are available at dixonandassociates.com. While the presented models focus on PFAS analytical datasets, such tools can incorporate any data of any type. Scroll down to the first data model on the dixonandassociates.com website. This model represents a PFAS soil and groundwater data library developed from California's GeoTracker database. Looking at the Power BI panel presented, note the double-headed arrow in the lower right corner. Click this toggle to allow the panel to be displayed in full screen mode. Select again to exit this mode or press the Escape key on your keyboard. If using the Escape key, the report will exit full screen mode and return to the Dixon and Associates website. Note that your selections are not lost and the last page you were on remains in the diminished Power BI panel. Simply select full screen mode in the lower right-hand corner of the diminished panel to return to the previous view. Along the bottom of the panel from left to right there is a link to Microsoft's Power BI website, an accounting of pages, in this case showing page 1 of 21, a sharing toggle and the full screen mode toggle. Above the Power BI base bar is a magnification or zoom slider and a fit to page toggle. Now, let's take a look at the first page or panel of the model. This panel contains 5 graphic representations to provide a summary of the dataset by location, by rank, and by analyte. Beginning from the upper right, we have a stacked bar chart, a standard bar chart, and a pie chart. From the lower right are maps representing sampling locations. This particular dataset was specifically curated to highlight georeferencing capabilities with sample locations estimated based upon information presented as figures and tables in various publicly available reports. In the lower left portion of the panel are several slicers or data filters. 2 have selectable sliders fitted with dynamic displays to show slider selections. The sliders allow selection of samples and sites based on contaminant impact rankings. In addition to ranking the samples from lowest to highest contaminant concentrations based on the sum of detected analytes, the slider totals show the number of samples and the number of sites within the model. This model represents 2,542 samples collected from 28 sites. As demonstrated here, the slider's inputs can be used to isolate individual samples or sample groups. These slider numeric displays are editable within the range of the specific slider. To directly input desired ranks, type the lowest rank in the leftmost and highest rank in the rightmost associated slider numeric input boxes. 3 additional slicers are provided. One allows checkbox selection of sites and samples of interest. To select multiple sites or samples, depress the Control key for additional selections. Use the slicer's arrow down toggles to view any site's sample set, and then use the associated sample checkboxes to select the desired samples. The 2 remaining slicers allow for isolation of the sample sets by matrix, in this case soil and groundwater, and of detected versus non-detected samples and analytes. Taking a closer look at each graphic, the stacked bar chart in the upper left corner displays sample ID or name on the y-axis against analytical results on the x-axis. The sample names are displayed in alphanumeric order while the analytes are displayed in an assigned order based upon chemical family classification. Use the graphic scroll bar located on the left side of the graphic display to view samples not shown directly in the display window. Use the left and right arrows to scroll through the analyte order legend. In doing so, you will see that a total of 39 analytes are represented. This indicates that any given sample in the dataset may have results associated with 1 to 39 analytes reported. Not all samples will have been tested for all analytes, and not all tested analytes are detected. The associated detected analyte suite for each sample are represented and color-coded on the stacked bar chart and as shown in the graphics legend. While the stacked bar chart displays the analytical results as concentration percent, the laboratory values can be viewed by hovering the mouse pointer over the desired portion of the sample's color bar or right-clicking on the graphic and selecting Show as a table. When viewing data tables, empty or blank cells indicate null values, meaning that analyte was not tested in relation to that sample. 0 values indicate the analyte was included in the analytical testing suite and the result was non-detect. Use the scroll bars to view the data. To return to the report page, click the Back to Report toggle in the upper left corner of the table view page. Note that the x-axis in this and other graphic panels indicate sum or max of result. In most cases, the unique associations defined between sample ID and reported laboratory data ensure that whether min, max, or sum is shown, the value displayed will be the same. Be aware that when looking at data summation graphics such as histograms, the use of min, max, and sum will represent aggregation of the entire dataset, group or subgroup as selected. When only a single sample is selected, these notations do not affect the uniquely associated analytical values. The second graphic is a standard bar chart very similar to the stacked bar chart, but here we display each analyte individually and are directly against the calculated value of concentration percent. Again, the sum of concentration percent simply represents the single concentration value available for that analyte and its uniquely associated sample ID. The third graphic is a pie chart representing analyte concentrations in both percent and by sum of selections. Here, M represents millions and K thousands. This chart will represent the sum of all selected sample analytes as concentration percent. When one sample is selected, only the analytes related to that sample are shown. Otherwise, the percentages are based on the sample set selected. Hovering the mouse pointer over the selected pie chart segment will allow a pop-up of the sample concentration or sum of concentrations by analyte for the selected sample set. The map graphic in the lower left of this page represents individual sample locations. Circles are randomly colored based on sample ID. Note that the colors will be repeated and simply allow for viewing contrast. Circles on this map graphic showing divisions indicate the number of samples associated with a particular northing and easting pair. Hovering the mouse pointer over the selected circle division will allow a pop-up of the sample associations. Alternatively, right-click and select Show as Table. The legend here shows sample IDs. To view a map graphic in full screen mode, select the toggle in the upper right of the map graphic. To return to the previous view, select the Back to Report toggle in the upper left of the full screen view. The final map graphic on this panel shows sample locations and their representative analyte pie charts as relative ratio plots with pie chart diameters indicating relative total analyte concentrations. Note that due to the method of ratio plotting implemented within Power BI, smaller diameter, lower concentration pie charts can occasionally be hard to see. In such cases, refer to the main pie chart graphic for relative analyte percentages. When using the graphic selection toggles, individual analyte impacts are reflected across other panel graphics. When more than one sample is selected, the pie charts represent histographic summaries. Note that the size of a site's aggregate pie chart will be greatly influenced by the number of samples collected and the associated values of detected analytes. Simply stated, in aggregation, the largest pie charts may not be associated with the most contaminated sites. Since these models are designed to be highly interactive, selection of a sample, analyte, or location on one graphic panel will immediately be reflected in the remaining panels. Selections made with the graphic panels are separate from the slicer selections and can be cleared by simply making the same selection again. For the most part, these graphics field selections will act as toggles. If you have difficulty clearing a selection, simply select the next page in the model and then return to the previous page, and the graphics field selection will be reset. The slicers or filters clustered in the lower left of this panel are linked to other panels, meaning that the selections made on one panel will be reflected in all linked panels. The selections can be modified on any of the panels using the slicers on that panel. Note that not all panel slicers are linked. This allows for appropriate filter selections relative to those panels. Let's take a look at the second panel or page of this model. At the bottom center of the current panel, click the arrow to the right of the page counter, which currently indicates 1 of 21. Once selected, the counter will advance to 2 of 21 and the page 2 panel is displayed. The second page of this model is identical to the first panel, but reflects analyte concentrations and percentages based on conversion to moles per liter. Molar values will be in the range of approximately 10 to the -4 to -6. As demonstrated, we can see that the percentage by molar concentration of PFAS excess for sample GWNE1DP is 51.41%. Returning to page 1, we can see that of the same sample by weight concentration, the percentage is 54.31%. Moving on to page 3, we present 3 histograms, one showing the sum of tested analytes, one showing the maximum detected concentrations, and the third showing a count of the analytes shown for the sample or sample range selected. Note that the filters on this panel are linked to the previous panels. Expand or reduce the sample range to facilitate data analysis. Also note that a histogram reduced to one sample is a representative bar chart and that histograms 1 and 2 will match. If we select the highest ranked sample, GWNE1DP, the analyte counts on histogram 3 will show all as ones. If we add the next ranked sample, MW04, the analyte count will increase when the tested analytes in added sample match those of sample 1, otherwise the count will remain 1. If the added sample was tested for analytes not included in the original sample, that additional analyte would be displayed with the number 1. Here we can see that PFDODA and other analytes were not tested in the second sample, MW04. These relationships identify the comparability and consistency of the dataset. The histograms on panel 4 are similar to those on panel 3, however here we examine the count of tested analytes against the count of detected analytes. Histogram 3 on this panel is a bar chart showing the maximum value for the sample or range selected. Hovering the mouse over the histogram bars provides additional information and, as has been previously described, right-click to view as a table. Panel 5 directly shows the molar versus weight concentration percentages for the sample or sample range selected. These graphics have been previously described and are similarly implemented here. Panel 6 is very similar to Panel 5, however here the bar charts show molar fraction versus concentration percent. This minor change normalizes the dataset and allows comparison of low concentration to elevated concentration samples regardless of large concentration disparities and matrix. This will be reflected in the stacked bar charts. Panel 7 focuses on molar versus concentration percent pie chart comparison. Panel 8 allows a direct comparison of 2 samples or sets of samples on their own pie charts. Note that each chart has its own dedicated rank sliders and matrix indicator filter. Also note that for the multiple sample comparison panels, molar-based values are used. Panel 9 allows a direct comparison of 2 samples or sets of samples on their own bar charts or histograms. These graphics will function as demonstrated for the previous panel. Panel 10 focuses on molar versus concentration percent radar or spider plot comparison. This is a single sample or sample set plot as shown in panels 5, 6, and 7, and therefore only has one set of filter or slicer controls. Dual or multi-sample radar or spider plot comparisons are available on panel 11. Select dataset tabular summaries are shown on panels 12, 13, and 14. These panels may also have graphic summaries. Selecting panel 12, we can see there are 4 tables. The first table shows there are 39 analytes in the dataset, the number or count of the times that analyte was tested for, and the associated maximum detected concentration. Further, this table shows that the dataset is comprised of 62,232 rows of data. At a minimum, each row represents a unique site, sample name, analyte, collection date, matrix, and reporting unit. As shown on the sliders, the 62,232 data rows relate to 2,542 individual samples. The tables further show that the highest concentration of all analytes is PFAS at 790,000 nanograms per liter. The next table shows the number of aqueous and solid samples by site. The two smaller tables summarize the aqueous and solids breakdown for the dataset as a whole and show the number of detected versus not detected analytes. The table in panel 13 presents a basic data summary showing sample ID, date, matrix, and tested versus detected analytes. A histogram displaying a count of tested analytes and 3 slicers to filter selections. The histogram could easily be modified to display summation or maximum values as previously described in relation to the histogram panels. The basic features of this panel are demonstrated now. The panel 14 tables display the reference values for family, class, and analyte-specific carbon counts. These are necessary components for family tree or heat plots as displayed on panels 15, 16, and 18. Continuing with panel 14, one table shows the PFAS class references that are included in this dataset, and a second table shows 17 condensed PFAS class references from which the first list was derived. The third table on this panel shows the carbon count by analyte and combines the PFAS class numeric developed in the previously described tables. Panels 15, 16, 17, and 18 display the data as family tree or heat plots, which can show each analyte count, concentration, sum or maximum concentrations, or even analyte acronyms posted against carbon count and family class. Simple use of color coding and value postings allows for quick assessment of analyte presences in the dataset. Panel 15 presents 2 matrices arranged as just described. The upper matrix presents analyte counts and the lower, a sum of the analytical data in the selected range. At the bottom of the panel, note the tabular results of selected samples, which is highlighted blue. Select focus mode to the left on the blue header to see the data table in full screen mode. To return to the report panel, select back to report in the upper left portion of the screen. If you use the escape key, the report will exit full screen mode and return to the Dixon and Associates website. Note that your selections are not lost and the last page you were on remains in the diminished website panel. Simply select full screen mode in the lower right-hand corner of the diminished panel to return to the previous view. On panel 16, the top orange framed matrix displays the sum of analyte concentration for a single selected sample or the sum of concentrations for any selected range of samples. The bottom matrix framed in blue shows the analyte's acronym. Note the matrix color intensity is linked to the concentration values. Panel 17 allows for direct comparison of any 2 samples or sample sets using the sample filtering methods previously demonstrated. Note that this panel shows concentration values. To view the associated analyte acronyms, use panel 18. Use of these panels are now briefly demonstrated. Note that the Power BI functionality provided in the published to web format is relatively limited in comparison to the desktop versions. While the model contains additional R-scripted demonstration panels, Power BI published to web does not currently support such visuals. These visuals do work well using Microsoft's Power BI desktop version. Finally, it should be noted that these models were initially created using Microsoft Excel 365, and every graphic contained herein was first demonstrated in Excel. Dixon and Associates hope you have enjoyed this YouTube online data model and library demonstration video. Please take a few minutes to explore the additional PFAS and other data models provided on our website.